Hello, AP Physics 1 and Cameron Gabor. Uh, Thanks for asking about number 7 in chapter 4. And without much further ado, let's get through this. So the question asks, what average force is needed to accelerate a 7-gram pellet from rest, all right, that means 0, to 125 meters per second over a distance of zero point 0.8 meters along the barrel of a rifle. And to be fair, the first thing that we'll do is to draw a picture, but I don't think we're going to need a free body diagram. So we have this kind of gun here, right? And in the gun, we have a little pellet, and it spans 0.800 meters. And we have some resting velocity and a final velocity and a distance. Unfortunately, I know for you, you're probably thinking, oh, I can find the acceleration as soon as I know the time. But really, I see VVATX here. ATX. So that's part 2 for us. We drew a little diagram, right? Initially, it's going to be at 0. When it gets here, it's going to be at 125 meters per second. So we know that V0 is 0. We knew that V final is equal to 125 meters per second. A is the thing we want. Time does not matter. So let's just draw a face like that. And then we know that X is going to equal to 0.800 meters. Fine. I'm hoping you guys already know your equations well. If you don't, the one thing that sticks out to me without time, no time, I'm probably going to use the VF squared is equal to VI squared plus 2AX equation. If not, if that didn't stick out to you guys immediately, check out your equation sheets. And I think this is kind of the biggest trick of this problem is knowing that you still sometimes need to use your kinematics equations. And all of a sudden, this becomes pretty easy. We know that VO is right here, is going to be canceled out. So VF squared is equal to 2AX. We want to find A, so let's divide both sides by 2x. That cancels. So A is equal to VF squared over 2x. And then this is 125 meters per second squared divided by 0.800 times 2, right? So I did that math and I got a number that was 9,770 meters per second squared. Okay, I just kind of did that math and I did a little bit of sig fig. So this is the acceleration, all right? No more question mark. 9,770 meters per second squared. All right, part 3 is the easy part. We know that F is equal to m times A. We want to know F, right? We know the mass. It's 0.800 grams. Where did I put? Oh, wait. No. I'm all goofed up. Mass is 7 grams. Mass is 7 grams. Aha. Mass is 7 grams. And then we know that the acceleration is 9,770 meters per second squared. Grams kind of sucks, right? We need to turn this into kilograms. That's just what newtons are. So we're going to say 0.007 kilograms. If that was too fast for you, to convert grams to kilograms, 7 grams times 1,000 grams in 1 kilogram, right? Good old dimensional analysis. Grams cancel out. It's just 7 divided by 1,000. I got 0.007 kilograms, right? So 0.007 kilograms times 9,770 meters per second squared. That's our friggin' F. So F, when you just multiply that through, I get 68.4 newtons. Hooray! So, what did I do to find this problem? This is the answer, and it is the answer in the book. Feels so good. First, I drew the little diagram. Once I saw the diagram, I knew I needed to do a kinematics equation, VV-ATX, old school stuff. Once I did VV-ATX, I was able to find acceleration using this formula, VF squared is equal to V initial squared plus 2AX. Then I just kind of did a little bit of algebra using Newton's second law. Thank you guys so much for watching the video. I hope that helps out. And thanks a lot for all the hard work. Bye-bye.